Next is the another case, that is the case of underdamped. Okay, in case of underdamped, alpha is less than omega naught. Okay, as you know that alpha value is how much, that is r by 2l, right? Omega value is how much, 1 by root lc. So we know the value of r, l and c. We can calculate the value of alpha and omega. If alpha is less than omega, then in that case that would be the case of underdamped. Clear? So that was the step number 1 for the underdamped. Next is step number 2. We have to follow the same steps. Step number 1, in the overdamped alpha and omega we need to calculate. Step number 2, we have to calculate S1 and S2, right? So similarly for the underdamped, in this case the roots are complex. Okay, the roots must be complex. So in this again step number 2, we have to calculate the value of S1 and we have to calculate the value of S2 as we have done for the overdamped case. Now but for the equation or formula for the underdamped would be different. S1 would be equal to minus alpha plus j root of omega naught square minus alpha square. Okay, and for S2 it would be minus alpha minus j root of omega naught square minus alpha square. Okay, clear? So in this we'll use damped frequency. What is the formula for the damped frequency? Omega d is represented by damped frequency and the formula for this one is omega naught square minus alpha square. Got it? So step number 2 is done. Now for the overdamped, step number 3 is we need to calculate the current equation, right? For this also, for step number 3 we have to calculate the current equation. Okay, for this the current equation is different from the overdamped. It would be equal to e raised to power minus alpha t, that is b1 cos of omega d t. I told you omega d is the damped frequency, plus b2 sine of omega d t. Got it? In that case equation is different, in this case equation is different. Okay, got it? Now what we have done in the step number 4, we need to calculate a1 and a2. Similarly here we need to calculate b1 and b2, right? So for this alpha we know, t is in the form of equation, omega d also we know because omega naught and alpha naught we already know. So for calculation of b1 and b2, what we have done, that is we put t equal to 0, right? Here also we need to put t equal to 0, that we can count as step number 4. Okay, put t equal to 0. If we'll put t equal to 0, then we'll get the equation I of 0 e raised to power alpha t is 0, then b1 cos of 0 plus b2 sine of 0, and you know that sine of 0 is 0 only, right? So from this we maybe they give in the question the value of I0, or maybe we need to calculate it. Got it? So e raised to power 0 is 1. From this equation can we get the value of b1, right? Because cos 0 is 1, b1 will get it. Again in the step number 5 we need two equation to solve it, but ever in the step number 5 for this one, remember we have differentiate the equation. In this also we need to differentiate the equation. That equation is it is equal to e raised to power minus alpha t b1 cos of omega dt plus b2 sine of omega dt. Now we need to differentiate, that is di by dt minus alpha e raised to power minus alpha t plus b1, right? Cos omega t differentiation, again we have to do all this differentiation. Okay, again after differentiating we can put at t equal to 0. Okay, after differentiation this cos will convert into sine, right? And this sine will convert into cos, right? Now when we'll put t equal to 0, then sine will become 0, then b1 will become 0, then cos 2 cos 0 will become 1, so b2. So from this we'll get the value of b2. Okay, from this step number 5 we'll get the value of b2, because we need to differentiate na, cos will convert sine, and if we'll put t equal to 0, sine 0 is 0. So in the step number 6 we can put down the values in the equation, that is I of t is equal to e raised power minus alpha t b1 cos of omega dt plus b2 sine of omega dt. Got it? Now alpha we know, b1 we know, b2 we know, all the values we already know, so we'll get it.